Okay, in this session we're going to look at the DataWindow to C# converter, and in particular what we're going to be looking at is how you can use it to rather quickly generate REST APIs. First, we'll have a legal disclaimer. Let's look at the agenda. First item, in case you don't know who I am, I thought I'd introduce myself briefly. Then we're going to look at creating a DataStore REST API manually. After that, we're actually going to look at how to create it using the scaffolding. So that's a lot faster way to do it based on some features in the Snap Develop IDE. The reason I want to cover the manual creation of the services, though, is that so you can understand how all the different pieces work together. That will become important when you're debugging it, if you need to extend it or modify it. If you go to unit testing and you need to do some stuff manually in the unit test class, that ASP.NET does for you automatically. So it'll make more sense when you get there if you know how all the different pieces fit together. We'll also look at creating a SQLModelMapper REST API manually. The difference between the SQLModelMapper and the DataStore approaches is that with the DataStore you can send the REST response saying the JSON back, can send it in a format that the data window can then use to actually see row and column status information. That's normally not the kind of information that's sent in a REST API request. So it's very powerful, but it's also very PowerBuilder specific. Whereas the SQLModelMapper just sends what I call the client agnostic format. So with the DataStore you can do both a PowerBuilder and a client agnostic format. The SQLModelMapper does just the client agnostic format, but it also has some additional features beyond what the DataStore approach can use, and we'll dive into that a bit. We're going to touch briefly on the PowerScript converter. I do have a separate session on this PowerScript converter where we look into it in more detail, but that's what you'd be using after you've used the data window converter to create the REST services, to go back into your PowerScript and move some of your business logic that's around those data window calls also into the C# class. And we'll look at how you can then use the REST API service from a PowerBuilder client to do CRUD operations, CRUD being create, retrieve, update, and delete. And then I'll just run through a demo of doing all this after we go through the slides. Okay, first a little bit about myself. My name is Bruce Armstrong. I work for a company called Integrated Data Services. I've been there since 2004. Prior to that, I spent 15 years doing independent contracting as PowerBuilder developer. When I joined Integrated Data Services, they were writing client-server applications using PowerBuilder for their customers. They're an ISV. We have since migrated most of that over to HTML5 JavaScript with Java in the middle tier. But we do have some customers that are still using the PowerBuilder version of the applications. In addition to PowerBuilder, things I'm fluent in are Oracle PL SQL, Java, C#, and I wouldn't say I'm fluent, but I do know C++. C++. Anyway, some open source projects I'm involved in. The open source PFC libraries, which most people I think are probably familiar with. I wrote a utility called PBNI SMTP that's a PowerBuilder native interface. It's written in C++. It allows PowerBuilder to send email via SMTP. And I wrote some plugins for Jenkins. One of those in particular uses the autocompile utility that was was introduced in PowerBuilder 2017 and is available in 2019 as well. It allows you to do command line compiles, so that what the Jenkins plugin does then is allows you to automatically fire off PowerBuilder compiles from Jenkins. That might be of interest to you if you're looking into moving into continuous integration. Okay, enough about me. A little bit about the company I work for. Let's look at creating a REST API. So there's a couple different steps here. The first step is you create a data context. In PowerScript terms, that's creating a transaction object, SQL CA. You then register there's two main files that we'll get into. There's a startup file and there's a program file that are common to any ASP.NET web service. So what you have to do in the startup is register the data context. What we're then going to do is create a C# model from the data window. We then create a service. We create a controller. And then we register the service once again in the Startup.cs file. At that point, you can run it and you'll have a working service. So let's look at each of those steps. First of all, now, this is actually creating the project. So if you open up Snap Develop and say that you're going to create a new project, select ASP.NET Core Web API. Fill in the rest of that information, and then you have three options to choose from here for sample code. There's Basic, which means no sample code. .NET DataStore means it will create some sample code for you using the .NET DataStore, or SQLModelMapper, which means it creates it using the SQLModelMapper approach. What we're going to do right now is create it using Basic. You could use one of the ones that creates sample code for you, and you could just change the data context and the data transfer object, and you'd have working service. The transfer object being the class that you create when you use the data window to C# converter. Okay, so this is what we end up with after we say, first of all, we're just going to create a basic ASP.NET Core Web API service. We've got the Program.cs file and Startup.cs files I talked about earlier. We have an app-settings.json file. That's where you store things like the connection string you use to connect to the database. You store it in a settings file so that you can edit that without having to change the application. So if you're doing development, you might point at a development database. When you're doing testing, you might point it at a test database, and then when you release a production, you point it at a production database. It will, even though we ask for no sample code, it'll actually create a sample controller for us, which we can just delete if we don't want it. Okay, so this is part of the Program.cs file. So you can see that what it does, about all it does is creates the host builder, and then this is it calling the startup file. So it's like the open event of your application, if you will, that just points to like the first window you open. It's not an exact correlation, but that kind of gives you some frame of reference. Here's the Startup.cs file. Now, any ASP.NET web application is going to have those two files, whether you create it in Visual Studio or in Snap Develop. What's different here when you create it in Snap Develop is it's going to throw in some things here that are specific to PowerBuilder added functionality. So in here where we have this reference to use core integrated, use PowerBuilder integrated, those you're not going to find those if you create a ASP.NET web service in Visual Studio, let's say. Those are specifically with adding the additional features that PowerBuilder gives you. And also, this is there's two main functions in the startup file. There's this configure services and configure. And so in the configure services, you have to reference to a couple of PowerBuilder specific things here. Down here in the configure, we also have the same thing. This dot use data window is specific to using PowerBuilder technology. Okay, so next step, we're going to actually create our model view and controller. I kind of mentioned those in the agenda slide. And generally, when you're creating an MVC application, Microsoft ASP.NET MVC application, You have your data context class, in other words, your transaction object. You have what are called plain old C# objects, which handle the data transfer. And then you have a data access class that actually uses the your data context class to go out and get the data and put it into the POCO objects. In the Snap Develop generated REST APIs, these two objects are actually in one class. That's going to be the only minor difference here. Then you'll have a view with a surface interface and an implementing class and a controller class. So the question you might have then is, why are we creating so many files for one service, one particular REST API call? And the reason is that there's been some evolution in thought as to how you're supposed to be doing object-oriented programming. When PowerBuilder was first released, or shortly after PowerBuilder was first released, there were some concepts on how to do object-oriented programming, encapsulation, inheritance, polymorphism. And PowerBuilder implemented that, but as object-oriented design philosophies changed, PowerBuilder didn't change with them, at least not till recently. And so what happened is things like design patterns aren't really accounted for, and this is model view controller is a design pattern. That's where that comes from. So if you want to find out more about design patterns and more specifically about the model view controller design pattern, I've got a couple links here to some pretty good introductions to those in the Coding Horror site. What they get to, and one thing that PowerBuilder doesn't do particularly well, is PowerBuilder doesn't adhere to what's called the single responsibility principle. SOLID is a one particular acronym that's in more recent object-oriented design approach thinking, and the S in it stands for the single responsibility principle. That is the idea. Is that you have multiple layers in your application, and each particular layer focuses on doing one thing and one thing well. So you have one layer that's responsible for interacting with the user. You have one layer that's responsible for implementing business logic. You have one layer that's responsible for actually interacting with the database. The reason you design an application like that is so that you can switch out one part and not affect the rest of the application. If you decided you wanted to change which database you wanted to work with, that would only impact your data access layer. If you decided you wanted to write a whole new UI for your application, you would only change out the UI layer, and the other two layers would remain unaffected. So I have a couple links here too for some things that talk about the solid principles, and particularly you can focus on the single responsibility principle. And then the idea of composition over inheritance. Inheritance isn't really favored much longer in object-oriented programming. The idea is composition, or the way it's most often implemented is through interfaces. And we're going to touch on this last piece here about why we don't want to use inheritance anymore, at least in these MVC applications. Here's an example of what goes wrong when you have inheritance. Right in PowerBuilder itself, you have a data store and you have a data window. And if you've looked at them in any detail, you'll realize they don't have a common ancestor other than PowerObject. You would expect that data window would inherit from data store. At least that's what I would expect. Because basically what the data window is the data store with some UI capability. But what happened was the data window was introduced first, and it wasn't until version 5 or so that the data store came around. And PowerSoft at the time had a choice: try to insert the data store into the inheritance path or create a separate object. And they went with create a separate object. And you've probably faced that same scenario in your own development, or this next scenario you might run into is that you have an ancestor called A, and you've created this descendant called, and you get another object called B, and maybe they're inherited off the same object, but you realize later that your object C that you inherited off of A should have been inherited off of B instead. And it's not, changing the inheritance in PowerBuilder is not a trivial exercise. It requires doing an edit source on the object, changing the ancestor type, and then dealing with all the compile errors you might get because it's now inheriting off of a different object. And that's not something you can do within the painter. It's something you got to deal with in editing source, which isn't always that friendly when you're working in PowerBuilder. Or a third scenario here is that you have class A, you have two classes, each that inherit independently off of A, B, and C, that have their own specific behaviors. But then you need to create, you discover later you need to create an object D, but object D needs to do things that both B and C do. And inheritance, at least in PowerBuilder, you can't have multiple ancestors. So you're kind of stuck. Interfaces tend to eliminate all these issues. When you create a class in your snap develop, you will indicate, or if you want to implement an interface, you just indicate in the declaration of the class that it implements an interface. If you need to change that later, you just change that declaration. You may have to implement a few different functions as a result of changing the class you're inheriting from, or sorry, the class you're implementing. But it's not the nasty kind of issues you have to deal with in PowerBuilder when you try to change inheritance. Also, if you have an object that needs to do what two other interfaces require, you just implement both interfaces. It's a trivial thing to do when you're using interfaces. Okay, so let's move on. Let's look at the actual steps. So we created our project. And we've got our program file and our startup file. Next step is to create a data context. In other words, SQL CA. We're going to right-click on our target. We're going to say Add New Folder first, and we're going to call the new folder Models. Now you're going to do that one time, but all your models will end up going into that folder. That's just a convention. You don't necessarily have to follow that. Generally, most MVC projects do follow that convention, though. I'm going to right-click in the Models folder, say Add, say Data Context from the dialog that pops up, give it a name, and then if you've already created some data context before, you'll get a drop-down list over here that will show you those that you've created before. Otherwise, you can hit New and create a new one. I'll show the new dialog in just a minute. And the databases that supported are MySQL, Oracle, PostgreSQL, Microsoft SQL Server, and SQLite. Adaptive Server Enterprise and SQL Anywhere are officially supported through ODBC. There's no native driver for them. Although you can create ODBC connections to other databases, it's not really supported. So you have to select this set. If you decide to try this with other databases, you're pretty much on your own. This is if you selected the new option, and it will vary. This will vary depending which database is selected, just like in the PowerBuilder IDE. So this is creating a data context for the SQL Server AdventureWorks database. This is what you end up with, and you don't really have to do anything with this at this point. That file just gets saved off. Okay, now I want to generate a C# model from the data window. Well, the first thing I'm going to have to do is go into my project, my solution once again, right-click, and say Open PB Workspace, and find the workspace that we're going to be wanting to pull the data windows from, and that will add it into our system tree, almost as if they were C# classes. You notice I've got a bunch of targets here. Once you click on those targets, they'll show up the various libraries and the objects, and then you can select the data windows out of them. So here is one where I've found a data window I want to work with. I right click on it and select Convert Data Window to C# Model. This painter will appear. There's a bunch of settings you can change here, but the main thing you're interested in is that button I've highlighted in red there. That's the export button. This dialog will come up, and there's some options you can set here as well. The one thing you're going to want to do is make sure you put it in the models folder and hit export. And what you get now is you get a file called that basically has the data window name. There's some options that you can change prior to that, where it doesn't necessarily have to exactly match the data window name. I like to take the D underscore off myself, but in this case I just left it on there. Notice that you get this is the models folder. What you get under the models folder is a folder for the workspace, a folder for the target, and then the data window that you brought over. I mentioned the plain old, it used to be called plain old C+ objects. It's also referred to as plain old CLR object. But what it is, a POCO is just a class that just has properties that represent the attributes in the data that you're going to be transferring around. But here's where it's a little different. The one we get from this conversion also contains some additional data. These are the attributes down here that we're going to be transferring. But this information up here, you notice we've got DW select. That's going to look familiar. That's your select clause from your data window. And the Snap Objects libraries know how to use this to retrieve the data. So this is not only our POCO object, but it's also our data access class. The reason you have a POCO object is so that you have an object that's not dependent on the inheritance or framework and provides loose coupling. So your data access layer just sends this plain old the POCO object up through the rest of the layers, and the rest of the layers don't know where that data came from and don't care. Okay, now we have to go back to the Startup.cs file, and we're going to add some using clauses for the Snap Objects libraries. SnapObjects.data and then SnapObjects.data whatever database you're using. SnapObjects is Appion's ORM for .NET Core. ORM is Object Relational Manager. There's a number of these. There's nhibernate. nhibernate is the .NET equivalent of Hibernate in Java. The Entity Framework is the other big one in the .NET world. That's the one from Microsoft. The Appeon argument is that the Snap Objects is faster and easier to use than Entity Framework, and it's also open source. Now, when I get into the SQL Model Mapper, we're going to actually use this library a lot more thoroughly. Right now, we're just using the data context. I'm also going to add a using clause for that models folder we just created. And I said, you in basic you don't get sample code, but you do get some sample code. One of the things it does is it includes the statements you need to use the different database connections that are available in SnapDevelop. And so one of those says SQL Server. So in this case, I take that first line. It's commented out in the generated code. I'm going to uncomment that line, and there's two changes I need to make. There's a context name that I need to actually give it the context class I created. And then there's a key, which indicates where in the app settings.json file, or what value in the app settings.json file, the key value, I need to use to get the database connection information. So you go grab those two values and you add those to the startup file. Now we want to create a service, and the first thing we start off with is the interface. So I'm going to create a folder called services, right click on that new folder, say add new item, and say add interface. And give it a name, and by convention, interfaces always begin with a capital I. I'm going to, in my interface, I'm going to add a using clause for dwnet.data. That's the other Appeon library, but this one's the one that actually provides DataWindow capability. It is licensed, but the source code apparently is available. I haven't asked for it. And in the interface, I want to just put in, it's essentially a prototype. It shows the methods that will get implemented in the classes that implement this interface. So in this case, because I'm using a data window, I'm going to take the approach where I'm going to be using the PowerBuilder specific JSON syntax. And I only really need two functions. I need a load function, or in this case I call it getAll, which retrieves the data as if you retrieve the data window, and the update statement as you update a data window. The data window itself determines whether or not it needs to do an add, a delete, or an update based on the state information it gets, and that's, with this PowerBuilder specific JSON format that includes state information for the rows and columns. That's something where we can just send back that state information in one call, and the service can then go through and determine what kind of an update it needs to make. So you don't need separate add, delete, and update methods in your service. Now I'm going to pass, what I'm going to return from the getAll call is iDataStore. It's the DataStore interface. And what I'm going to pass into the update method is the iDataStore, the DataStore interface. Because you can also do, well, there's a couple things you may want to do. You may want to do client agnostic approaches with the DataStore. Or just from a UI perspective, you may want to have separate add and delete methods, because maybe you want to fire those off as soon as the user doesn't add and delete. You don't want to wait until they update an entire page. And you might want to have a get method where it retrieves a single row as well. The sample code that's available on the Appeon website for this session has all those functions implemented. I'm just going to show you the getAll and the update. So we've created our interface. Now we need to create a class that implements that interface. What I'm going to do now is actually go to the services folder and create a folder underneath that called Impl. And I'm going to make sure that all my interfaces go in the services folder, and all the classes that implement those interfaces go in the Impl folder. Once again, that's a convention. You don't have to do it that way. That's generally how people do MVC applications, though. Then I'm going to create a new item in that folder and select class and give it a name. And then as soon as that opens up, I'm going to, well, one of the things I'm going to do is I'm going to add in a reference to the DWNet.data and test services. I'm going to say this is how you implement an interface. I put a colon name behind the name of the class. I'm going to add iCustomers. That's the interface I created earlier. And the minute I do that, I get these little red squigglies underneath iCustomers. You say, well, what's wrong there? Well, if you hover over it, this pops up, and it says, you've said that you've implemented an interface. There's certain methods in that interface you need to implement. If you're actually going to implement the interface, these are those methods. You can click. One of the things, options it has here is a show potential fixes, and you can click on that, and it will ask whether you not want to implement the interface explicitly or just implement interface. If you select implement interface, it will actually throw in all the methods. It won't implement them for you, but it will throw in all the methods so you know what you need to implement. And by default, it adds this not implemented exception. Okay, so before we get to implementing those, though, there's a little structuring we need to do. Remember the data context? Well, what we need to do is we need to add a reference to the models folder and declare a private instance variable of the data context. And then we're going to add a custom constructor for this service that takes the data context by reference and assigns it to the instance variable. At that point, we can then use that data context in all our methods. Now let's go back to the methods. What I'm going to do is create a DataStore object that is of type iDataStore, the interface. Say equal new DataStore. I'm going to give it the name of the data window. It's actually the POCO class we're talking about here. And I'm going to pass in the data context. So this is, if you will, somewhat like your it's your set data object and your set trans object in a single call. Think of it that way, and it'll make a little bit more sense to you. So you've got a data window or a data store, and you create the data store, and then you say data object equals, and you give it the name of data window. And you say set trans object, and you give it the name of a connection object. You're doing that in a single call here. You're creating the data store, giving it the data window, and giving it the database connection. Then what do you do in PowerScript after you've done that? Well, you do a retrieve. Well, that's what I'm doing. I'm doing a retrieve. Now, the -1 isn't magic there. The way I created this data window, if I pass in a positive number, it looks for a customer that has that ID value. If I pass in a negative number, it just returns all the customers. And so that -1 is just a key in my data window to say return all the customers. And then I just return the data store. So this is pretty simple code, something I think most PowerBuilder developers could pick up pretty quickly. That makes a lot of sense to them coming from writing this in PowerScript. Also the update. So the update passes in a data store. I'm going to just take that data store, say set the data context, because remember the data store is coming back from the client. It doesn't know anything about a database connection, so we have to remind it, oh, here's your database connection. So we set the data context to give it back its database connection, and we issue an update. That's it. Real simple, very PowerScript-like. Should be pretty easy to pick up. And as I said, all the other methods are in the sample code. I'm not going to go through them right here. So we've done like 3 of the 4 steps we need to do here. Actually, it's 5 steps. We created our data context, which we only have to do once. We created the model by converting the data window. We created the interface. We created our service. We get 2 more steps. We create our controller, and then we register that in the startup file as well. And then as you create additional services, you go back and create your next model, your next interface, your next service, your next controller, and register it. You do those 4 steps over and over again for all your different services. So anyway, we're going to go in and create a folder called controllers and add a new item there, and we pick out the API controller class. And we actually get some sample code, even though we didn't pick that. But what we could do is actually just modify a few of these if we want. Rather, like there's an update method there already, although it doesn't take what we need it to take. And there is a load method here, although it doesn't. We got to change the arguments and return values to use them, or we just throw them away. But like the service, there's a little frameworking we have to do here. We have to go in and add a reference to the services class and create an instance variable of iCustomers, the interface, which is a reference to our service. This is, I'm sure I kind of named this poorly. I should call this customer service to distinguish it from my data object a little bit better. And then I'm going to create a custom controller. A custom constructor. That custom constructor is going to take the service by reference. So when you create your service, it takes the data context in its constructor and assigns it to an instance variable. When you create your controller, it takes the service as a reference and assigns it to an instance variable of that service. And now we get to call that service from within our controller methods. We're going to add a few more using clauses here. One is the system.links. One is to our models class. One is to dwnet.data. And one is to Microsoft.asp.NET Core.http, because we're going to use some HTTP codes in our code. System.links is in there because we're going to be doing some array manipulation, array to list. So here's an example of the load method. I've actually got, ignore this part, that's the custom constructor from earlier. But I've modified that load method, so now it returns a list of D customers, which is our POCO object. Action result is just what the container class, if you will, of what ASP.NET MVC web services return. I've put in here a produces response type 500, which is the error code, and indicated that it's the get method. That I think most of that was pretty much part of that sample code. But here, what I'm going to do in the in the actual method is I'm going to create once again a reference to DataStore based off of the DataStore interface, and I'm just going to call the service method, the getAll method on the service. I'm going to check to see if the row count is 0. If the row count is 0, I'm going to return a not found error. If it's not 0, I'm just going to return the results from that are in the data store. But here's where system.links comes in. Is I'm going to say that what I'm going to do is return it as enumerable, indicate the POCO class that I'm returning, and say to list, and that actually returns it back as a list. And then this is the update method. So if you're familiar with the HTTP verbs, you'll remember that get doesn't take any data except URL parameters. If you want to send data, you have to use one of the other verbs. Most of the time, post is used for that, to send data. And when you send the data, it doesn't go obviously in the URL parameters, it goes in the body of the request. And so in our update function, I've added this from body declaration, this tag. And the reason I've done that is actually has to do with if you use Swagger, which is a utility for documenting your web services, Swagger goes in there and reads that, and that way it knows that when it documents the service, that this is what needs to be passed in the body. It's so anyway, we have an action result because that's what these services return. We have the update method, we have the from body declaration, we have it passing in the data store, just like the service method gets. What I'm going to do is do a try here, try to do the update. That the reason I put it in a try block is in case this throws an exception of any kind, and I'll just return a 500 code. So within my try block, I just call the update method on the service and see what the result is. If it returns a -1, that means I got an error. It didn't throw an exception, but I still got an error. So once again, I will throw back a 500, which is the HTTP method of saying there was an error. Otherwise, I return OK. So the only thing that actually gets returned from this is basically an OK result or an exception. And I've reiterated this several times, but the other methods are shown in the sample code that's available from the Appeon site. Okay, so if you just did all that and ran your service and called the API, you'd find it wouldn't do anything. In fact, it would give you an error telling you that the API couldn't be found. And that's because there's one more step we need to do here. We need to register the service with the startup file. So what we're going to do is add the services folder and the service Impl folder into the using clauses in Startup.cs. And then here, this code, almost all this code was provided for us. There's the database connection information line I commented out. Here's the other ones for the other database types. The add GSIP compression was part of this, what was spit out for us automatically. But here I'm going to add services.addScope, and it's going to contain a reference to the service interface and then the actual service. And that's how you register the service with the web host. And now it knows to actually listen on the URL for service requests. Well, how does it know what URL to call? Well, that we know that by going back to the controller and look at a few things here in the controller. So the controller has a particular name. In this case, it's called REST Demo Controller. You see the route says API / and then it has controller in brackets. What that means is take whatever the name of the controller is, chop off the word controller, and just use the rest as that part of the URL. And then it says, and then it has a /action in brackets. What that means is find the method name, in this case load, and just put it in there as the URL. So the URL for the load method then becomes API/RESTdemo/load, and the update function, which you can't see down here, but it's called update, would be API/RESTdemo/update. So that's how it knows what URL that it needs to listen for requests on. I mentioned this earlier, but the from body is you don't actually have to have it there, but if you decide to use Swagger to document the service, then it helps Swagger. Okay, so we're ready to run the service. Now, one thing that can help, it saves you a step. This is the debug tab, and if you go in the debug tab, there's an option that whenever you run the service, it will automatically launch the browser and call a URL. And so that's what I've done here. Is I've said launch the browser and run my RESTdemo/load method, and that way when I hit run, my service starts running and the browser automatically opens up and calls the service. I mean, you don't have to do this step. You could just run the service and then open up the browser yourself and type in the URL, but thought I'd save a step. When you hit run or F5 within the IDE, it's going to run a self-service host. and it will listen on 5000 for HTTP or 5001 for HTTPS. If you decide to use HTTPS, the first time you run, you'll get this dialog. The reason is because what it's going to do is it's going to create a self-signed certificate. And so you're going to get this error because it's going to try to add that self-signed certificate into the certificate store, and it's a warning saying, do you really want to put a self-signed certificate in the certificate store? And go ahead and click yes, and it won't prompt you again after that. Okay, and then this is the service running. So there's the IDE in the background. Then you've got this command window. That is the self-hosted service running. And then you've got the browser running and the JSON for response displaying from the service. You can do it manually. What you can do is you can go to the command line and go to the folder that the assembly got deployed to, and type .net space and the name of the assembly, and it basically does the same thing, runs it then in the console. Okay, so now we've looked at how to do it manually, and that seemed like a lot of work. We're going to see how we do it with the scaffolding feature, which is a lot less work. But like I said, I think it's important to know how the pieces all fit together, and so you don't rely on the scaffolding and not know what you're actually generating, because then if it comes to debugging or extending what's been generated, you wouldn't know how to work with it. So what the scaffolding feature does is it automatically performs most of what we just did manually. We still have to create the model folder, and we still have to create the data context, and we still have to register the data context in the Startup.cs file. Here's where remember I said you by default what you're going to get is the POCO object is going to have the name of the data window. Here's where you change that. You go into you click on this expansion icon here, and you go to where you've selected the data window, and it's going to show the data window name here by default. You change that to indicate what class name you're actually going to want to use. And I'm going to do this specifically when I use the scaffolding, because it's going to base everything it does off the name of the POCO class. And so if you put D underscore in the name of the POCO class, everything it creates is going to have D underscore in it, and I don't want that. Okay, so once you've created your data context and you've created your POCO class by using the data window converter, you can right click on the POCO class, and you'll see two options come up. One is just to create the controller, and the other one is create both the service and the controller. So we're going to select that second option, and this dialog comes up. What this does is allows us to customize how the generation is done. In particular, there's a number of different templates available for how it's going to generate the services. Whether it's going to create just the retrieve and update, like I showed you earlier when we did it manually, or if it creates retrieve, update, delete, or if it add, delete, or if it even creates both the client agnostic and the PowerBuilder specific versions of the services. So yeah, a lot of options there. Main one you'd probably be interested in is the template. Also, there's a drop down here for whether or not you're going to use the data store, which allows for the PowerBuilder specific format, or the SQLModelMapper, which is just the client agnostic version. So there's if you choose the data store model, there are 3 templates. Data store for PB client, that's the retrieve and update methods. That's pretty much what I showed you when we were doing it manually. Data store for non-PB client, that creates retrieve 1, create, update, and delete methods that send out and take in non-PowerBuilder specific code. It's just the plain old JSON. Or the third option is DataStore for any client, and then what it does is it generates all these methods, so that you can call it. You will have services. You have services that you can call from both a PB client using the DataStore specific methods, and any other client using the non-DataStore specific methods. I should point out, PowerBuilder can use the agnostic methods, but it's there's some advantages when you're using PowerBuilder to using the PowerBuilder specific one, and we'll get into that. SQLModelMapper only has one template. That is to create all the client agnostic methods: retrieve, retrieve one, create, delete, and update. And while we're here, I'll just launch into what the difference is. Why you would want to use the DataStore approach, particularly if you're using a PowerBuilder client. And it goes back to what I've said several times here. When you're using the DataStore, what gets passed along is row and column state information. So when you go to do an update, the DataWindow can actually generate an update that says, update this row and this specific column in this row with this data. REST services don't normally do that. What happens with REST service, when you send an update, REST services are generally stateless. So the server doesn't know what the original, when you send your update, the server doesn't know what the original values of the data was. All it basically does is replace what it just found, what it finds in the database right now with what you sent up. The only way you can actually ensure that you don't get a data conflict, an update conflict with a REST service, is to include a last updated timestamp or some sort of GUID value in the database, so that if you retrieve a row and somebody else retrieves a row and then they do an update, when you go to do your update, the GUID or the last date updated timestamp won't match, and you know you'll have an update conflict. But if you don't do that, you'll never know you have an update conflict. And so if user A selects the data, user B selects it, user A updates, and user B updates, user B will overwrite user A's updates. So just something to be aware of. That's just the nature of REST services because they are stateless. And PowerBuilder, using the DataStore approach, avoids that issue. Okay, moving on. So this is what got generated for us. So remember, we had this originally, the POCO object, or if you want to, well, the DAO object, depending on which one you call it, because it's really both. And then it created the customer, the service interface, the service, and the controller all for us. So there's only one step we need to do now beyond that, beyond what we've done already, and that's to register the service in the Startup.cs file. It's the only part that Scaffolding doesn't do for you. So you see, it's a lot simpler to do it this way. Do your data context, which you only do once, because you're just gonna have the one connection to the database. You export the data window to C#, right-click on it, say generate the service controller, and then register it in Startup.cs, and you're done. And you can just keep doing that, the last few steps over and over again for each additional service you want to create. Okay, so let's look at the SQLModelMapper service, see how it's different. It's an alternative to the .NET DataStore approach. It's completely open source. It's no dependent on the DataWindow technology at all. It does contain a pure separation of concerns, but that means that it's going to be a steeper learning curve for PowerBuilder developers. It's actually probably your existing C# developers, particularly they're already used to Entity Framework, are probably going to feel pretty comfortable there. It's the PowerBuilder developers that are going to struggle to move over to it. So the way you create the service using the SQLModelMapper is, instead of passing iDataStore all the time, we're just going to pass cut the POCO object in and out of the service. It does have additional capability beyond the data store. I don't remember if I actually mentioned this earlier, but it can do complex implicit transaction. It can do nested models. The issue with the data window is the data window is a flat array. And so if you've got more complex data than that you want to use in your service, you probably want to go look at the SQL model mapper, because the data store is not going to, all it does is flat arrays. And you also can use raw SQL in the model. So you can extend the service to do all kinds of different select statements. So we're going to look at how we create the SQL Model Mapper service instead of if we do it manually rather than the .NET data store approach. As before, create an ASP.NET Web API project. When you do that, if you just if you just say basic, it will actually still include some references to DW.NET libraries. So you need to actually remove those. I mean, you don't have to, but they're not going to be used. So just go ahead, you can go ahead and remove them. Well, the other option you can use is actually specifically call out the SQL Model Mapper in the sample code, and then just delete the classes or whatever you want, or modify them if you want to implement what you want to do. Same as before, we need to create the data context and register it in Startup.cs. You can go ahead and use the DataWindow C# converter to create the POCO class. That's a nice quick little shortcut, because what you need is a POCO object, and using the data window convert to create it for you is a nice kind of little hack to do that. What you can do is, once you've generated that C# class, is you can remove like the DW.NET using clause, and then anything that shows up as an error because you removed that, because that won't be used or needed when you use the SQL Model Mapper. Otherwise, you can create that class manually. It's not terribly difficult to figure out what you need to do there. Okay, we need to create a service interface. So it's pretty much okay. Well, there's two differences to what we did before with the .NET data store. One is I have more methods, because remember that the data store can take the insert, updates, and deletes in a single call. The REST, the normal REST service can't do that because they don't send state information. So we're going to have separate create, update, and delete methods rather than just one generic update method. And we've added a retrieve one here, where if you just want to retrieve one row. The other difference is, remember that the retrieve and the update passed the iData store. What we're going to send back now, this is the POCO class. This is an iList of the POCO class and an iList of the POCO class. Okay, so now we create the services Impl class. Declare an instance of the data context, same as we did with the .NET data store, and the custom constructor. That doesn't change. Then implement the SQL model mapper. Now, see, this is not good. This isn't the syntax that your PowerBuilder developers are going to be familiar with. It's not terribly complex. You're going to just say, take your data context. The SQL model mapper is an attribute, actually, of the data context now. And you say .load, and you pass in the POCO object, and then you just say to list. For the retrieving one, you say load by key, pass in the POCO object, and give the ID value that you're trying to find, and use the first or default. For the update, what we're going to do is actually retrieve the current customer, the current value in the database, and then do a track update, and after that save the changes. Okay, if that, hopefully that makes sense to you. And the other methods are shown in the sample code for this session. I'm not going to go through them right now. Okay, now we're going to create a controller. As before, you're going to create an instance variable to service. You're going to create a custom constructor that takes the service as an argument, sets it to the instance variable. We don't need to add dw.net.data here because we're not using the data window, the data store. And then, as before, when we created the web API controller, it actually created some sample code for us that we could just modify. So the change here is, once again, this was passing iDataStore before. Now we're passing the iList of the customers, and we just called the service method. And here, once again, it used to be iDataStore. Now it's iList of the customers. Poco object, the front body's still in there. Here, this really didn't change much at all. I'm just doing an update, checking the result. You know, the calling the service method, checking the result, throwing an error, and catching any exceptions and throwing an error. So that really didn't change too much from the one that was the data store, other than the data types passed into the methods. And once again, the sample code has all the methods that I just showed those two. Once again, this doesn't change. We still have to register the service with the Startup.cs file. Okay, so regardless of which path you chose, whether you decided to go with the data store or the SQLModelMapper, now you've got your REST service that does the basic retrieve, update, delete, add operations. But you've probably got a bunch of PowerScript in your PowerBuilder client too that has the business logic that surrounds those retrieve and updates, and you want to get that over into the REST client as well. So the way you can do that is you go back into your project and add the PowerScript bridge library to your project. Now I do have a separate session where all I do is I talk about the PowerScript converter. So I'm not going to go into a huge amount of detail here, just kind of cover it briefly. If you're interested in that, I would recommend checking out either my session or I'm sure there's other sessions here at Elevate 2020 that cover the PowerScript converter. But anyway, you add PowerScript bridge library to the project. You've already got the PowerBuilder project in your Solution Explorer. You were working with the data windows before. Now you can go down there and you can find, let's say, the window or the user object that data was being used in, data window was being used in, and double click on it and it will open up in the editor. And then you can find functions. You actually try to convert the whole object. I wouldn't necessarily recommend that. I probably recommend doing it a function at a time. But you can right click on a function and say convert it to C#, and you can either put it into the clipboard, or you can open up just have it open up another editing window and it will just show it to you side by side to your PowerScript code, and then you can just copy that into your REST service and apply it either before or after the insert, update, delete operations. So here's an example. This is where I'm doing DW modify. This is actually from my other session where I go over the converter. So this is on the left is the PowerScript code. So we're doing describe on the data window, get its select statement. We're finding whether or not there's a where clause involved. If the where clause is in there, if the where clause is not in there, we add it. If the where clause is in there, we remove it. So this is just the toggle back between a where clause that a SQL statement that includes or does not include a particular where clause, just for an example. And then we use DW modify. I've been using PowerBuilder a long time. I still refer to these as DW describe, DW modify, and that syntax actually still works, but that's not the current verbiage. But so anyway, we do a modify to put the SQL select statement back into the data window. So how does that work in C#? Well, once you've got the PowerBuilder bridge in there, it actually works fairly similar. Obviously, the data window can still do a describe. That's still a method on the data store. Part of what PowerBuilder Bridge does is it adds functions, PowerScript-like functions, to the .NET classes. So now your string class actually has a pos function and a left function, so that this code pretty much converts directly over. You wouldn't normally see this in C#. So that's your position statement getting migrated over. Then we, we're just doing our if else, standard C# if else, and using the left statement over here now that matches the PowerScript left statement. And then once again, we're using modify to put the modified SQL back into the data store. So that's how that works. So let's go on to CRUD operations. This is using this REST service we just generated from a PowerBuilder client. Maybe we've stripped out the data access layer and some of the business logic, moved it up into the middle tier. We still have our PowerBuilder client that we can call those methods now, and the users can still use. So if your client is PowerBuilder, you're going to probably use the REST client object. On the server, it's a question of whether or not you're going to use the DataStore service or a SQLModelMapper service. As I said before, PowerBuilder can call the SQLModelMapper methods. It actually can call, you can take the .NET DataStore and still create client agnostic services. And PowerBuilder can still call those as well. You'll just have to you'll have to separate out your adds, deletes, and updates is the main thing, because when you're passing the plain JSON, there's no state information, and so from the client you're going to have to explicitly determine: do I want this to be an add? Do I want this to be a delete? Do I want this to be an update? Rather than just letting the data window handle that for you. This is what I talked about a bit earlier. I kind of jumped ahead of this slide. There's the PowerBuilder specific implementation that uses the data store, and there's a client agnostic implementation that can be done with either the data store or the SQLModelMapper. The main advantage of SQLModelMapper is there's some additional functionality there if you're going the client agnostic approach. Not other REST clients though can't use the data. Well, they could if they did a lot of work, but normally most REST clients aren't going to be able to use the data store JSON format, and so you'd use the agnostic format done by either the data store or the SQLModelMapper. So this is once again, the sample code's available from the Appeon website. This is my sample. I'll show this here in a minute as well. So I've got a data window. I've got a drop-down data window that allows us to select between the data store and the SQLModelMapper implementations. Insert and delete here actually just insert and delete in the data window. They don't. That doesn't call the update methods on the REST service. The update method on the REST service, regardless of whether or not you're using DataStore or SQLModelMapper, I'm handling in the update. Although, I think I mentioned earlier, you may want to send your inserts and updates more directly. If the user adds a row, you may want to actually send that outside of any separate update statement. That's up to you. And in actual practice, I'm just doing this for a demo. You're probably just going to want to settle on one of these two approaches and just use that rather than trying to implement both. Or maybe you want to do both. Maybe you're going to have a PowerBuilder client still, but you're also going to create some other clients, and you want to use the PowerBuilder specific services for your PowerBuilder client and the REST services for your other client. Your client agnostic services for your other clients. So maybe you would have You might have both, but you'd still probably just use, in that case, you just use the data store, I imagine, because it can do both. So this is the an instance variable in the window, which is the REST client that we're going to use to do our REST operations. And I have an instance variable that keeps track of what the user selected in the dropdown that toggles between the data store and the SQL model mapper. This is the open event in the window, so I just instantiate my REST client there. There's a couple headers that I'm going to set that I want to go on every call. Since we are sending the data as JSON, so I'm sending the content type data to JSON UTF-8, and I'm turned on gzip encoding. gzip encoding is actually turned on by the server. This flag says go ahead and use it. If you send this flag to a service that doesn't use it, it'll just ignore it. It'll just send you back plain JSON. What happens, I think I mentioned this much earlier on, but what happens is that if that flag is sent and the server does support it, then it will gzip the data before sending it down. That will help increase the transfer speed, but there's a little overhead in the compression on the server side and the decompression on the client side. But PowerBuilder does that decompression automatically as well. So I set the current item in the drop-down list box to the first item, which is the .NET Data Store. This is my retrieve end event. Whoop, too far back. Basically, I'm just, if there's no, I'm not sure why I've disabled insert here, but certainly delete should be disabled if there's no rows in the data window. This is the selection changed event of the drop-down list box. Just lets the instance variable to know which option was selected. The reason I want to do that is I've got some functions here that depend on what the value is, and rather than go and get the value off the drop-down list box, or trying to, I just grab it off that instance variable. So here's the insert, and just for convenience, so I didn't have to enter the information, I hard coded it into the button. So anytime you hit the insert, not only do I insert the row, but I actually put the data in there as well. So I'm using one of the newer options for the PowerBuilder data window, the import row from JSON that imports a single row of JSON, and then the item status, the new modified, so that will do an insert if we use the data store approach, or that I'll know that it's modified, a new modified. So when I use the client agnostic methods, I know I need to send an add method call. This is the delete button, and surprise, surprise, it does a delete row. This is the there's this window function I was referencing. Whoop, too far. I was referencing earlier, where I'm looking to see which service they selected, and I'm changing what I did in this particular case. I've got I created a separate data store demo and a SQL model mapper demo, and I toggle between them to show the data store specific and client agnostic approaches. Like I said, you could have done both with the data store as well, but I want to show the SQL model mapper in the demo. This is the retrieve button, which in a sense does a retrieve. It doesn't do a retrieve on the data window, it does a retrieve on the REST client. So what happens is we reset the data window, we go figure out which URL we're calling, and this just gets the base URL, and then I add the method I'm calling behind that. So, and I happen to call the method I'm going to call. That's one advantage of writing two different services, is I can make the method name the same. So there's in the data store service, the retrieve method is called load, and the same thing in the SQL model mapper service. So I pass in the data window as an argument to the REST client retrieve method and the REST API I'm calling. This is the update event. Update button. So I'm doing accept text, kind of the standard stuff you do with the data window. Send power, set pointer hourglass, just the user knows something's going on. Here I'm getting the base URL again because I'm going to be referencing the update for the data store approach, or the update add and delete methods for the client agnostic approach. And then I'm branching based on what whether I'm using the data store or the SQL model mapper. So in this case, for the update, there's only one method call, because remember, we're passing all that state information with the JSON, and so we can send it in one call. So once again, we're using the REST client and passing in the data window to the REST client method. In this case, it's called submit. We pass in the URL, so it's the base URL plus update. And once again, I made the method name the same between the two services. The response is just where we can get error information back in case this call fails. And there's a couple flags here. The first flag is whether or not you're just sending all the rows or just the changed rows. And obviously, if the data hasn't changed, there's really no reason to send it, right? So I send it true. If I've only updated one row, let's just send that one updated row. That's something else. That's something you can do. And then the format is whether or not we're going to send plain or data window JSON. Remember, I said the PowerBuilder client can use both. And this is an example of where you could set this to false, and you would just be sending plain JSON to a client agnostic service. In this case, we're actually going to set it to true, though, because we do want to take advantage of the one pass for all the updates that the data store does support. So now this is for when the user selects, or when you select the SQL model mapper approach. So it's a little more convoluted. We got to do a little bit more work because we have to separate out the calls into three methods, potentially. If the user's done inserts, deletes, and updates, those need to be three separate calls because the REST service is stateless. So what I'm going to do then is I'm going to loop through the rows in the data window, and I'm going to check their item status, the row item status, to see if it's new modified. Remember, when you hit insert, I set that row to new modified. And this is the typical stuff you do to see if a row's been inserted in the data window. You check its row status. What I'm going to do in this case, though, is I'm going to export that row as JSON, and then take that exported JSON and use the send put request to send it to the add method in my SQL model mapper service. You'll see that there's a couple different approaches here. The way I created the SQL model mapper service, I use delete, the delete verb. So it send delete. The reason this says send delete request is this is the HTTP verb. So my service takes the delete call on the delete HTTP verb. It takes the update on the post verb, and I use the put verb for add. You don't have to do that. What a lot of people do is they use get for retrieves and they use post for all updates, and that's an alternative. So this could have read send post, send post, send post. That just depends. It just depends on which verbs you use for the service. But like I said, I used put for the add, delete for delete, and post for update. So there's the URL being formed by operating off the base. Now for delete, I've got a slash there because the delete doesn't really take any data. All I need to do for delete is just pass in the ID value that I'm deleting. I don't need to send the data at all. Notice I don't have an export row as JSON here. I'm just grabbing the item number I'm deleting. If it's in the delete buffer, I'm just grabbing the ID value for whatever I'm deleting and passing that in that single call with no data other than that this is part of the URL. And then like I said, for the add, we're just sending the add one row at a time. Now for the update, we can actually save a step here. We don't have to do it a row at a time as we're doing here. So what I'm doing here is I'm saying export JSON, and I'm saying just export the changed rows and do it in just plain JSON format. Okay, so now I have all my updates, just the updated rows, exported as JSON, and I send them in as the data here. So what I'm doing in my service, my SQL Model Mapper service, is if I get rows in on the update method, those rows get updated. There's no state flag to check. So you would only send rows you're actually updating. Last thing I do, because it's the REST client that sent all this data, the data window doesn't know that the data has been updated to the source. And so we do a reset update to clear all the state flags. Okay. Before we end, though, I did promise several times throughout this session that I was actually going to show how this works. So we're going to do a few demos, and then we'll come back to this slide. So here's the PowerBuilder client that I was showing you earlier in the slides. We'll go ahead and run that. You see I've got Snap Develop running in the background. I've got the service running in self-hosted. Notice I've got two different controllers, one that does the data store, one that does the SQL Model Mapper. As I mentioned in the session, you could have written one service that had all the different methods, both client agnostic and PowerBuilder specific, particularly if you use the data store to do that, because it can support both. But I wanted to show the two different approaches separately, SQL Model Mapper in particular separately from the data store. Anyway, so here's the data store and SQL Model Mapper options. I'm going to retrieve using the data store. So there's our data, and it actually came back pretty quick. Of course, we're operating on the same machine here. And I'll change this to an H. I'll delete this guy named Bruce Armstrong down here. And then I'll do an update. And I'll retrieve the data. And notice there's the H. That row I deleted is gone. I'll do an insert and do an update again. Remember the insert, the way I code this, the insert method doesn't actually send the data. The update method is the way that sends the data all the time. And do a retrieve, and sure enough, that user's back. So that's all the operations working with the data store. And remember, it's just single retrieve, single update. All the updates are sent in the one update call. And then this is the SQL Model Mapper, and we'll retrieve. Once again, it's snappy. We're going to change another middle name, and we'll delete the row here, and we'll say update. Now the difference here, let me just retrieve, make sure that worked. The difference here is, well, let's do an insert too. Okay, so the difference here is that there was more than one call. You might have even seen that happening in the background, because the inserts, the deletes, and the updates are all sent separately, because we're now using the REST stateless services to send the data. Okay, I guess that's it. We can go back to the slides. So last thing I'll point out here is community.appeon.com. Most people are familiar with that. If they are familiar with it mainly because of the Q&A forums there, but there's a lot of other information up there. There's blog articles. I've got a bunch of blog articles up there, and sample code. And so the sample code that I've shown you during this session is available on the website. So if you want to download it and go through it yourself, you certainly can, and I'd recommend that. With that, thank you for your attention, and I hope you enjoy the rest of Elevate 2020.